Test, test. Hello, ladies and gentlemen, boys and girls. My name is OctoMan, and today I want to do some kind of a live session how I solve problems, and we're gonna take a look into procedural content. So first off, what is procedural content in Unity? So the first thing is to understand what this can do for us as game devs, and probably to solve problems in a total manner. Of course, I gonna change the thumbnail later on, so I hope you are not confused about it. Anyways, well, what is procedural content? Procedural content is something which is automatically generating content for us. That means when we have something specific like a ladder, and we want just with sliders define how a ladder is going to look later on, like when we just put in 3D material or 2D material, that everything is basically generated automatically for us. So with the help of coding, of course. So what we are going to take a look into is how we can actually do procedural content, how we can create a ladder which is automatically like resizing, do us through some like taking some points, which we can take as measurement, and based on the measurement, we're gonna change the 3D model I have created already, as well as filling like how many stairs we're gonna have on a length of 1 meter, for example. So it is automatically decided to the settings we are going to make and implement. So this is a live session, so I never made something like this before. I have not pre-calculated stuff already or anything, so I just tried to figure that on the way. Meanwhile, I'm figuring that you're gonna have the possibility to check it out. We're gonna talk about coding and stuff like that. So this might be a bit longer session in total. So, but what we're gonna take care or take a look into is just the model is going to be this one. So how do I prepare things is basically I just model them. I have a course about 3D modeling using 3ds Max somewhere over Udemy, so just check it out if you like to. Learn how to model things in 3ds Max. If you want to go with Blender or any other modeling software, feel free to check out other videos. I have nothing about Blender, but yeah, that's the deal. Okay, so let's take a look pretty quick what the scene is about or what the models are going to be about. So I have created just a ground plane over here to visualize things. And what I want to have is a ladder, like a setting, where I can, for example, say, okay, I want to define the length of the foot. I want to define the length of the stair and how many we're going to have, like without doing copying and pasting. What does it mean is when you, for example, have one of these stairs over here, you can, of course, do like a duplicate, then you bring this downwards and, copy and paste all of that. But let's assume we don't want to do this because not we are lazy. We are more or less like we want to have something which is automatically filling space by just giving us the possibility for inputs. So in a total, when we gonna do the just the normal way, we're gonna select all of this content over here, take the foot and the legs and all the other stuff, and then we're gonna do like a Control D to duplicate, of course, then we flip it over, and basically that is our ladder. Then I forgot, oh no, I forgot to put this piece over here, so I need to duplicate this again, bring this all over the place, and of course I would have a ladder. But let's assume I want to have the same ladder, but it should be like on 2 meters height. Or let's assume it is a slimmer, or I want to change the length of the stairs. I want to define the difference or the distance between those, or just make sure that the stairs are going to be longer or shorter. Or maybe I want to rotate it, or I want to rotate like all the ladders and so on and so forth, or all the stairs in the same time. So to do that, we gonna need to do some programming, of course. And what I want to implement is something that we have in our inspector. Let's say several sliders and some points where we're going to start from and calculate width and height and all the other stuff by using scaling, and of course later on probably check out how does it look when we have a texture on that. So what do we need to check out on this particular textures, and how do we need to set them up so that everything matches later on when we have, for example, scale up and down these letters. And what I want to do is I want to basically create a prefab, which is, yeah, basically we can just drag it into the scene, place it wherever we like, resize it according to whatever points we are going to take. And in the end, we're gonna do something like just automating the fill over the complete distance, like wherever we are going to snap our little helper tools, I would say. So that's what we're going to create today, and I hope we are going to do a good content over here. Once again, I have no idea about the outcome, so let's take a look into this pretty quick. First off, the most important thing over here is going to be we need to have a placeholder for this. So a placeholder means I just need a little, let's say, empty game object, which is basically the foot or the base, the ground of my actual letter setting. I'm gonna delete all of that stuff because we don't want to do copy paste. We want to have a placeholder for all this content and make it so that on our base of the model, like which is probably somewhere on the ground where we want to place, that is everything based on that is going to be connected to that, like as several different prefabs and stuff like that, so we can automate once again the fill and gonna instantiate content based on the settings and the input directly inside this one placeholder. So what I do usually to to fix, or actually to go on to these problems I'm gonna have, is at first I'm gonna create an empty game object, and most of the time just zero this one out. So it is like sitting directly under the foot of my letter piece already over here. So what I want to do is that all these pieces need to be connected to this game object later on. So once again, we can do this like directly inside as a prefab or whatever. So we can make these prefabs, then instantiate the prefabs on runtime or basically on editor time. And that's what we want to take care of. So I'm going to rename this one just to be our, let's say, a letter game object. So everything related to this object will now change. What we can do for graphical representation at the moment is we can take all the letter parts we already have over here, and I make them child of the letter. So wherever I'm going to bring this letter game object, so the empty one which has nothing else but that as child objects, it will always follow. Same for rotation. When we later on go and rotate our letter into whatever direction, everything else is going to do follow up. So what we want to do is we want to take this once again as a placeholder for all of that information. The next one is what I would do is I would need another game object which is defining the width and the height of the letter itself, so we can later on scale it procedurally and fill the content in between points by the correct amount. So basically the bottom over here of my letter is going to be this one. So I can take this as the first measurement point between 2 points. What I can also do is I can create another empty game object, and you can also take any 3D object if you like to and later on make stuff invisible. Yeah, maybe we're gonna do this. Let's create a cube and scale this one super small down. So once again, what you take does not matter as long as you see what you're going to do. I'm gonna maybe do it 0.05 in all three axes, so I have something to grab on, but also to reposition things. I'm gonna lift this one up to be at a 1 meter spot, since I know that the length of my leather foot is 1 meter. So meaning this is also my point to measure things. So, and I can rename this cube to be my, let's say, top goal. You can also use an empty game object. This is just easier to grab, I would say. And what I want to do is based on the bottom letter part over here, it seems that my that I need to refresh the scene in a second, because as you can see, the pivot point of the top goal is now at the bottom and not at the top where it should be. That is a problem Unity 2K19 rather often has whenever we do stuff like that. So even if I would go and grab this one outside, you can see the pivot point is anywhere, and I can't change anything to this. So yeah, not a cool one. I'm gonna check this out in just a second, and we'll just launch Unity, because probably that is the best way I can do over here. Okay, so this is the top goal, and I'm gonna save my scene pretty quick and try to reload this. I guess there are, or probably I can just refresh something, but I think, nope. I need to restart Unity for a second. So give me just a moment. I'm gonna destroy the scene pretty quick and restart it. This is just a checker map I used, by the way, on the bottom of the playfield. So I'm back in just a sec. Gonna start my Unity hub, and if you are working with several different Unity versions, you should use that as well. Gonna try to reload the complete Unity yeah, project over here. I guess I need to get sooner or later a new Unity version, because the pivot point switches are rather horrible. So once again, if I now select top goal, you can see that the actual pivot point is going to be here. So what we want to do is we want to take this as a distance, yeah, calculator, I would say. So between our bottom, like the initial object, and this is going to be the one which is defining the size of our ladder foot over here. Also, it can define, let's say, where the second ladder part is going to be. Like, we're gonna later on have two ladder parts, and this one over here is going to determine the distance between those, as well as the distance of the second ladder foot, as well as this upper area over here is going to be defined the same way. So everything based on this second object over here. So the measure, the top goal. So basically also the length, whenever we have that, for example, over here inside the ladder, then we are able to go and bring the complete size of that based on this particular goal. We're gonna start at one, since once again the length of the ladder foot of my side, or in my side, is going to be just 1 meter over here. So same for the stair width is going to be the same. We're gonna define the stair width between this top goal and the bottom goal, basically, or the ladder itself. So the ladder main game object, as well as this top goal as well. And also we can then define how many stairs we want to have in between those 2 points. And that's what we're gonna do. Once again, calculate procedurally over the time. So what we now do is, on our ladder itself, we need to make sure that we're gonna have a script which is going to take, or is going to do all the work for us. So I'm gonna create a new C# script, and I call this one, I don't know, procedural ladders, or just ladder. And what we want to do is we want to put into that, once the compiler is done running and stuff like that, gonna maximize or maximize here. Gonna open this, some firewall warnings will pop up, and then we are hopefully good to go. So, and this is going to be the script which is actually handling all this content for me later on, I hope. So whenever my mono developer is loading, I'm using a special version of that, because actually usually it does not work anymore with Unity, but just with that version, which fires several problems over here. So bear with me. I'm gonna need to make sure that all of these are going to go through, since the builder of mono behavior and so on and so forth is going to be needed. So now you can see surface has been loaded. So we don't need start and update. We just need to make sure that we put in enough information, I would say, to have the legs, or basically the second leg, which we can position somewhere. So that's where I would start first. Also, probably it makes stuff easier when we have this already repositioning based on the top game object. So this top goal. In this case, the very first thing is the top goal is a game object, but the most of the time we're gonna need just transform values, probably a local transform values. So I'm gonna take a transform over here, and I would say this is my top goal object. And based on that transform, all the informations or the vector data based on our game object, we're gonna reposition that in runtime. And to do that, we're gonna have two possibilities. The most easiest one whenever you create procedural or any type of content is you're gonna work in the Ondro gizmos, let's say, layout, because this is running in edited time and we can test things out rather quick. So what we can do is we, for example, have a second ladder, let's say foot length or foot length setup for that particular one, as well as all the pieces need to be connected to our procedural ladder script over here. So let's start with the first leg. So this is our ladder. Let me just do, this is a game object, I guess, because we're going to take care of the scale. Maybe it's not going to be the game object. Maybe we're going to take transforms here as well. Well, basically, yeah, let's just try it out. So we're going to take of type transform. Once again, we need the vector information over here. And let's say this is the left leg. We're going to later on need to define what's left and right, but just start with that. Then we're gonna have a transform for the right leg. You can also type all this transform in one line. Basically, it doesn't really matter. So with that transforms connected to our setting over here, we're gonna be able to scale them up and down. And speaking of that, we're gonna have this void on draw gizmos. So it needs to be written 100% correctly, otherwise it's not working. So it's on draw gizmos with O, D, and G. You can always check out the scriptable or the scripting API on Unity side somewhere where all this information about the on draw gizmos function is going to be done. So what we want to do is we want to calculate the distance between our actual goal or our actual start, which is going to be at 0, 0, where the procedural ladder game object is going to sit, and then the top goal. And this distance is going to be, once again, starting with 1 meter. And we want to scale down left and right leg based on the top goal position on a relative, on a actual local or relative way. So to do that, we can store this information somewhere if we like to, for example, in a float. And we can just say it's going to be a distance. And what I would try out right now is just calculate the distance between the top goal in the z-axis, no, the y-axis actually. So because that's the up changing axis. Hi, Erol. Thanks a lot for tuning in. And then we're going to have, we can calculate the distance on these two vectors basically, and we can calculate the length from that. So, and we can basically take the one and the other and just say this minus that is going to be the length. Let's test this one out. So, and since we want to, put in only the z-axis, we probably just read it directly from the transform of the top goal over here. So meaning we can now take the actual transform position x, so or in this case it's not the x but the y-axis once again. So transform the position dot y, and we can actually say we want to negate this one from, or we're gonna do vice versa, because we're gonna have the other one. The top goal is going to be the one where we need to take this one away. So top goal dot transform dot y. So, and when we say we're gonna take this one and we negate it by that one, we're gonna get a distance. So let's see what's going on over here. There's no definition for the y-axis since we need to say dot position dot y. Okay, so and well, it just flipped away. Sorry about that. So gonna do a transform position dot y. So basically we're gonna take this position, or actually the top goal position, and negate it by this position, and then we get a distance. And based on this distance, we now should be able to scale up and down the size of our left leg and our right leg, but only on the y-axis. And this is the most important thing, I guess, over here. So let's try this out. So we're going to talk to the left leg. Of course, we need to later on make sure that all of these are going to be filled in. So if there is basically nothing inside this transform left leg, then we don't want to do anything and don't want to spit out errors or errors. So to do so, we can say if left leg is not equal to null, or the right leg is not equal to null, so right leg not equal null, then only then we want to do the calculation and the rescaling basically. So what we can do now is we take left leg and put this over here, and this has a transform.local scale variable, and we can also split this now apart and can say we only want to talk to the local scale y over here. And we want to take this scale to be equal to the distance. The downside on that is, as you can see, it is not possible to talk to the local variable directly or to the local scale this way. So what we need to do is we need to store this information first into a new vector or whatever, and then we're gonna push the complete vector data into this transform area. So probably we're gonna not take a transform, but a yeah, we're gonna take probably a vector and then put this into the transform over there. Let's just try this one out. So, and we're gonna just later on go and update the transform. Oh, we don't even need to take the transform over here because we talked to that already. But still, as you can see, it is just red underlined and we are unable to do this. So what I want to first do is probably put a scale vector or something over here. Just try it out. I don't know. Once again, this is a live session. I have never changed or tested this one before, so I'm gonna just try with you together basically. So this is our scale vector, and we're gonna flush in the data we want to have. So in this case, we just create a new vector3. Probably this is not a good method, so we are not going to optimize things at the moment over here. So what I want to fill in is the actual transform of, or the actual scale of the left leg. So left leg dot local scale dot x. Then I'm gonna fill in the overridden distance over here on the y-axis, and then we're gonna take the left leg local scale dot z, because, well, we're gonna take just this information we at the moment have and put this into the scale vector. What we can now hopefully do is we're gonna take this local scale and set this one equal to whatever the scale is. Let's see if that works. Looks good. So now we just created a new vector and put all the information about the scaling from our left leg into this. And now we want to update left leg based on the scale. So when we change distance, since this is running once again in editor time, we're going to be able to do the scaling over here. We can do the same, by the way, for the right leg as well. So I'm going to override just this ones to be right leg. But the downside, or actually, we don't really need to do that. Whoops. I don't know what that comes from. Just delete it. I don't know. So since we don't need to rearrange the complete local scale because we already have calculated this, we can just take the right leg and update the local scale of the right leg with the scale as well. So we're gonna do the calculation only once. So we just need to update the right leg over here. I guess that's the most optimal way. So we don't need to recalculate everything for the right leg because, once again, the lengths of both letter feet or legs are going to be the same. We can basically just copy that or save the script. There's one more thing I want to make sure is that the top goal over here is only calculated when there's a top goal in there as well. So we're gonna put another if statement. So if top goal is not equal to null, so we actually did something at least, then and only then we want to create or calculate the distance between those 2 points. Otherwise, we don't have them. There's one downside to this. We cannot access now the distance because it is now only part of that. So in this case, we're gonna just put in the distance, the calculated distance outside of everything. Like over here, we're gonna keep it private so it cannot be overwritten. And then we just update the distance over here, and we don't need to change anything by that. So we just have this one as an extra. I'm gonna save that and go back to Unity, and yeah, let's see if that already works. So there's one more other thing. We only have one ladder lag, so I'm gonna have a ladder lag for the left one. So I need to create a second one, which is going to do the work for us. So basically, we're gonna do later on the same for repositioning the second ladder lag. So first off, I'm gonna rename this one to left ladder lag. Then I duplicate this and name this one right ladder lag. Because we're gonna need both, otherwise the script will not work, as you probably noticed already. What I also want to do is I want to take this procedural ladder part and bring this over here. When you have null reference over here, then you forgot to check if there is a top goal or not. Now I drag the top goal into the top goal area over here. Now I take the left ladder lag and bring this over there. Now we have an unassigned reference exception or something like that. We're going to take a look into this, as well as the right ladder lag. Probably it is I need to do an AND operator here instead of an OR operator. So this unassigned reference exception for the right leg is not coming up and should be hopefully updated. Okay, so what we now can do is we can basically take the top goal, and of course we can do it left and right, but that doesn't change the right ladder port or the left. But when I now bring this one down, what you can see now is based on just that one, we're gonna trim down automatically or scale down this ladder lag. So what does it mean is we now have a control point where we can actually scale our object into any size. Pretty decent, right? So we now can do is we can also reposition now the right ladder lag based on this little object. To do that, we're gonna take a look into repositioning right now. So as you can see, this ladder or this goal over here is currently representing the x-axis. So when we later on rotate our ladder over here, it will still be the x-axis based on this ladder. This is important, and that's information we need to understand. Okay, so we have now our top goal, which is measuring the distance correct. Now we need to have a second distance, which is the x distance. I'm gonna maybe create another x distance over here. Maybe the other one, gonna rename this maybe to be the, what is it? The y distance, basically. I'm gonna update it so that all the other ones are going to be updated with it. So we need an x distance here as well. So in that case, it's not based on, once again, the y-axis of the actual position, but on the x-axis. And so basically we just copy this content or this distance over here and fill in the x distance for that. So we're gonna take the top goal transform position.x related to our current distance.x and check this one out again. What we now can do is we can, whenever this is updating here, first I'm gonna make a command, maybe this is about scale, and the next one is just something like a reposition on x. So make yourself or do yourself a favor and make sure that you always put yourself some line comments over there, so it is better for you, I guess, to optimize things. So what we want to do is we want to maybe keep the right leg at position, and we're going to take the left leg and reposition this one to the left. So we're going to say left leg dot transform dot position is going to be equal to, and now we can basically recalculate this based on a new vector 3. And in this case, we're gonna take its current y position. So we say transform dot position dot y, or basically the object position over here. Then we're gonna, well, not this one, that's bad. We want to take the x distance over here. Maybe I do have a calculation error, but we're gonna see that. So once again, we wanna shovel this one to the x-axis or over to the x-axis based on the top position. We can also or could take the top goal on x position. Basically, it doesn't really matter. We can do both. And this one is going to be our x distance to or related to our current position. So we'll see if that works. Then we're going to have our transform dot position dot y and the transform dot position dot z or z. So I'm gonna save that. So I just reposition once again the left leg over to the axis. Let the compiler run and see what's going on over here with the left leg. As you can see, the left leg automatically repositions now wherever our goal is. Cool, so now we can decide or define how far away our ladder leg has to be from this, from this point over here. So great, so now we know how far away this is. We can probably do this in the negative, yes. Sometimes when you move the goal a bit too fast, you can see there's a little offset. I'm not quite sure if you can see this, do it to the stream, but it's like flopping a bit here and there. You can basically ignore this because it's updating once again in editor time, and we don't really need to take care of that as well. If you want to have this bottom ones here, like this bottom parts, if there are any, you can probably put this directly onto the lag as a child and later on enable and disable that. So basically this ladder caps. I guess this is a ladder cap. So what I mean by that, I just duplicate the ladder cap and make a child of the right, or in this case left ladder lag. And then I make sure that I reposition this on X as well. So what does it mean now is when I move top goal, the bottom is going to follow here as well. Pretty decent. So what we can now do is we can now define the height and we can define the width of the ladder. Gonna bring this one up onto the y-axis in 1 again. Basically, x doesn't matter for me at the moment. So next point is basically we can do the same for the tops over here. So the ladder top, then that we are going to have one over there. I'm gonna duplicate this and bring this also as a child onto the left ladder leg and reposition this one to the other side. So the next option, or whenever you create such ladders, you might want to give the option that these ones are going to be enabled and disabled. So these ladder caps, basically, or this ladder tops. So to do that, we just make use of a boolean or something like that, where we just enable and disable that. And based on the boolean setting, we're gonna have to do this. Also, we might not need a transform for that, but maybe game objects. So we're gonna say is a game object because we just want to set them active or inactive based on the boolean. We can do this into the onDrawGizmos function here as well. We're gonna change this function in later on, so just bear with me. We're gonna do eyeball all these things first in onDrawGizmos. So we're gonna have a left cap or left ladder cap, and we have a right cap. Once again, you can put all of that also, as long as you don't need to or have any specific things inside over here, you can just write all these content into one line of code. What we want to do is we want to enable and disable that. So we say public bool enable cap or visualize caps. A problem with this bools later on might happen in updating that correctly. So whenever bool is enabled, so you don't want to change the bool with code. You only want to change this by input. So what we can say is basically we set left cap and right cap whenever they are visible, of course, or whenever they are in the scene, or whenever we have dragged them inside this game object slots. So if and now once again, we do the same null check as we did before, just to protect it and don't have any hundreds of, thousands null reference exceptions. So if left cap is not equal to null and right cap is not equal to null, then we want to make sure that we are reacting to everything based on this bool. And since it's a public bool, we can always see this in editor time, and we can basically enable and disable left cap at any time we want. So what we can say is left cap dot set active, and in open close parentheses, we're going to put in the enable cap. So whenever it's enabled, of course it's enabled. Whenever it's disabled, we're going to do the same, vice versa. So basically, if we do both for the same, so right cap dot set active to be equal to whatever enable cap is. So whenever, once again, this is going to be on, then those are visible. Otherwise, they are invisible. Let's test it out. Let the compiler run pretty quick and see what's going on. We go to our ladder game object where this option is selected, and currently it is just invisible. What I now want to do is I want to drag in left cap and right cap. So in this case, it's these tops basically. So maybe I'm gonna rename them pretty quick. So I'm gonna do a rename or refactor and just name this one a left top and enter. And this one, I'm gonna rename this one. This is the, let's say, right top. Something like that. So they are just updated here in the bottom as well whenever you use this renaming function stuff. I'm gonna save the script pretty quick and go back to Unity, let the compiler pretty quickly run, and let's see what's going on over here. So we take the ladder top. In this case, it's for the left ladder, so naming convention is king. So maybe you want to rename this ones here as well, or you just select them and you know what they are. So this is the left top. And we're gonna have the right top is basically this one. I'm gonna rename them so right ladder top so I can see the stuff better. And I just drag the right ladder top over here. And this one is going to be the other one. I'm going to rename this one to left ladder top. Good. And what's going to happen now is, as you can see, if both are inside, they are deactivated automatically. Why? Because our enable cap is in standard being disabled. So whenever we enable them, you can see they got enabled. When we disable that, of course, it takes a second or two, they are going to be disabled. Pretty good. So now what's going to happen is we have to reposition these caps based on this top object here as well. So if the pivot point is correctly, then I just need to reposition this one in the in this axis. As you can see, this already follows because it is child of this object over here. But this one is not doing the same stuff. So, or is not updating with it. So once again, this is because, I guess, of I did not added everything to the ladder over here. So let me update this pretty quick. So first off, I'm gonna set this one to 1 just to make sure everything is aligned again. And now I need to look what's going to happen over here, why that ladder top is going to reposition with it as well. So I'm gonna go in code and just check it out if there's something strange happening, but I guess not. So I don't know. Let's see if we are going to do the same for the right ladder leg. So I'm gonna have the right ladder leg over there. I'm gonna take the ladder cap or the right ladder top and bring this as a child over here and this one over here as well. So we have just those two legs with everything connected to it, hopefully. I don't know. So let's see what's going on. Good. So now we can take this topping because I just made sure that they are connected to each other. I just can now scale stuff up. But as you can see, there's a strange behavior going on. Whenever I do this pretty high, you can see it is also scaling my ladder tops. So this is not what we want, I guess. So the best deal over here is we're going to talk to these ladder tops separately instead of scaling them with our ladder in this case. So to do that, we of course need to implement the ladder tops externally, or basically need to make sure that they are not part of our right ladder leg or even left ladder leg. So what I do with that is I just bring them away. We need to reposition them by hand or basically by code. So I'm gonna take both tops and bring them outside so they're not rescaling with that. And I need to make sure that they're following the correct target over here as well. So the right or the right one is basically not even touched. We just need to adjust the height for that, and the left one is going to be the one which needs to be height and like the x and the y axis position based on the scale. So, and to do that, we're gonna put basically everything over here as well to reposition them. So here we just say we want to enable and disable stuff. And in here, we're gonna make sure that we are repositioning or reposition. So first off, let's go with the right cap or the right top. So right top needs to be repositioned. So right top dot transform dot position is equal to a new vector 3. And what we need to do is basically we're gonna keep staying where we are, but we need to make sure that we are taking the y distance in its height. So, and the x distance is basically staying the same wherever we are currently at. To do so, we just take for x, since it doesn't change in x, we just take transform.position.x, so our main object. Then we're gonna have the y distance, which we are going to take, and then we have the z or z value, which is going to be based on our current object. So we don't need to take care of that in this case. And that should be everything for the right top. So let's save and see if that works. We're gonna let the compiler run and see what's going on. By the way, if you don't have any 3D models like these, you can always just use internal stuff. I now take the top goal, and as you can see, when I now bring this one up and down, it follows the complete distance. Hi, Oscar. Welcome to the party. And there's one more small thing which we might take into consideration is the pivot point needs to be corrected, I guess, over here for that, because it might not be at the correct position, but doesn't really matter for the sake of testing, I would say. So left and right, nothing changed. In the z-axis, nothing should change here as well, and just the height should be updated automatically. If we if we do not want to change anything on x and y based on the transform position of the game object in the bottom, we might be able to put in any fixed numbers. So I'm gonna bring this one down onto y again, and let's see if that is just something where we can take any nice number over here on x. I guess it's just something small. We need to fiddle around with that just a bit. Actually, we can also say we want to go on what is it, the x-axis or the z-axis? I'm not sure. I try to set this one to 0. Once again, that should be relative to the game object, which doesn't really matter at all. Maybe we're gonna add something to it. Once again, need to make sure that all the pivot points are going to match completely correct over here. I don't care about that. So let's see if there's something going on. Well, let me just comment the stuff out. I want to take a look in and see where we can put the local position to this. And maybe we can just play around with some numbers. So, and I'm gonna try to zoom out just a bit so I'm not having too much trouble with that. So let's see. That looks okay. So it's a rather small number over here. So probably I'm gonna put this rather small number. I just copied that and bring this over here. So make sure that I put an F over there. So just a correction phase in this case. And now once the compiler is done running, it should be always at the correct position. So whenever we are now moving the ladder to the left and to the right, okay, we're gonna have another problem. That's good. And we're gonna take a look into this in, let's say right now. So what's happening? Why is that not relative? Because we did not took our axle transform position into consideration. So based on the world axis basically, and we're gonna have the changes to the local. Let me check again. So as you can see, this one is moving based on that, but this top one is not moving based on that, as well as not this one. So I guess we need to add the correct or the current position, the current world position to this as well. So let's see. We're gonna take the x distance, and I guess, we're gonna take our transform the position and add this one to it. So transform the position dot x. So the left leg should now follow. If that doesn't work, we're gonna need to take a look into it even more. So compiler is done running, and now you can see the left leg is following correctly onto the x-axis as well. We don't care about the y-axis or z-axis. As you can see, the only thing we need to update right now is this part, though the right one over here. Since that is not relative to the game object, but only local, or in this case, it's the based on the world axis, we need to add this to this as well. I don't care about updates. So what we now need to do is we're going to do the same as we did before. We're going to put in the transform.position.x into consideration for the x-axis onto this right top part as well. And I believe we're going to need to do the same over here for the y distance. Since it's going to be, well, no, it's the height. This is just repositioning. Let's see. I guess that works, but we'll see in just a sec again. So I gonna go and take the letter, and now as you can see, I can reposition this one in X, in Y, and I should also be able to do this in Z. But as you can see, once again, in Z, even that doesn't matter or doesn't work, because again, we did not implement the transform to position dot Y-axis over here, because again, this is a local thing. So transform dot position dot Y plus Y distance. Good. Let's save this out and check again. And we should be able to freely move this one into any position we like to. Okay, now we can put this one up and down, left and right, forward and backwards. Good. So we now have that together. So what we now need to take care is of these stairs, right? So we want to automatically fill enough stairs into this with a specific distance as well. So whenever, for example, we're gonna take our top part over here and bring this up. That's funny, we forgot to put the other one. So let's finish that first. Whenever we're gonna put this up, that these stairs are going to be filled automatically or maybe visualized automatically, whatever. And what we first need to do is we need to reposition the top left, at the left top as well. So we say left top dot transform dot position. We want to reposition this left top as well. And for the moment, it's just following with the complete part over there, but it is not going to go into the height. So in that case, we need to say it's equal to, and probably going to take the complete calculation based on that, but we're going to add the x distance to this as well. So I copy this complete part, and in here, we're going to need to say plus the x distance, I guess. And that should be anything we need for the left top repositioning. I let the compiler run. We're gonna need to check it out. So as you can see, now we can go and move left to right. We can do up and down. That doesn't matter because we do not affect the Z axis overall. So we now can define already the correct size of everything. Good. So next one is about these stair parts over there. So we have just one for visualization, and now we need to actually, think about how much or how can we do this, because I believe that's the hardest part in this complete manner. We want to have or we actually know the distance over here, and probably we can give it ourselves a number, how many stairs we want to have in between those. based on the distance. So, and based on that, we want to make sure that we reduce the distance between those based on the settings we're gonna do. So, for example, we're gonna have like 5 stairs on over 1 meter. Now we want to make sure that the when we divide 1 by 5 stairs, that the lowest bottom is going to be the first parameter for that. So we reposition that. Also, we need to make sure that we're gonna have enough stairs to visualize. And that is probably the biggest problem we are going to encounter right now. We need to make sure that we have enough stairs onto that. I have Currently, I don't know how to do this, Joe. Just take a look into this and let's see what's going on. We want to reposition the stairs once again based on the settings. So first off, I would go and create a public setting for us. So we can say maybe, for example, we can take the distance between that. So it's automatically calculating the amount, or we can say the amount and it's automatically repositioning the stairs we're going to have. Basically, both work. Let's say we're going to start with a float. And we say it's maybe a stair distance. So a distance between those separated stairs. Maybe we're gonna calculate this with that, and we're gonna start maybe with 30 F. So it's always a float number over here. And what we can do with that is we can calculate this based on our x distance, or in this case y distance, and divide how many we have. We just need to round this, of course. So let's create a round function for that first. Gonna close the on-Gizmos just a sec to see how we round things. So void round number. We can also, instead of taking a void, we can also return something like a float. And or in this case, I want to have a rounded integer back. And I want to fill in data and this, or basically request a data for that or from that. Procedural and a round number, not all code is going to give me back a pass, of course, because we need to return the result later on. So what we want to return as a result is the actual x distance. So we're going to take x distance and we want to divide that by the stair distance. What we want to do is, since that gives us back a float instead of an integer, as you probably see already over here, as a problem, or whenever you start coding, stuff like that, you're going to see, okay, that only returns as float. So we need to typecast this into an integer. But by typecasting that, it's not rounding it probably correctly. So what we can take is probably a helper function called messf dot. Is there a round function? I don't know. Probably round to int. So returns f rounded to the nearest integer. And I guess round to int might be a good number. And we're gonna put in any float and we get a rounded number back. Good. So easy to round stuff around. I guess we're gonna have the possibility round it up or round it down, and based on that, we're gonna get a result. So, and this result can be taken as calculation for the distance between those stairs. Now, just since we know that these stairs are going to be over there, we now need to think about how can we just make use of this amount of stairs and show enough stairs of that as a copy or whatever. And this copy is probably the most the most hardest part over here, because in runtime, to instantiate stuff in runtime, it probably is not a good idea. So maybe we're gonna need to go into editor scripting for just that particular part, or maybe I'm gonna find out another way which is maybe a bit easier. Maybe we can just do an easy duplicate, or we're gonna fill a list with objects. Um, and so we have them all prepared, and we just enable and disable the correct amount of stairs or possible stairs. For example, we can it's basically like a how shall I say, like a hmm Yeah, it's like a object pool basically where we can grab from, or where we can just go through and activate and deactivate the correct amount of what we want to have. But we need to fill this list with information before we can do that. So let's assume this will be stairs like all over the place, and probably we're gonna, that's a little cap in this case. Let's try that out. I have no idea. So we're gonna create a list. Lists are dynamic placeholders like arrays, but arrays are not dynamic, they are just fixed numbers. So with lists, we can basically fill in information more or less how many we want. And please, I'm just not sure how we can do this. Let me just try the instantiation method or part over here. Okay, so let's assume we're gonna have a rounded number of the distance over here. So in runtime, or whenever we do stuff, we're gonna make sure that for this particular amount we're gonna have somewhere, we're gonna do something like, let me just put in the stair number. Once again, I have no idea how to do this, so I would fix that or put that together. So I just try things out and try to go around the program or around the problem I'm gonna have. So at first, I would say I would try to yeah, put or fill values inside actually the stair number. So after x and y distance have been calculated, because these are necessary, I guess at least the x distance is necessary. So based on the top goal we're gonna have over here, I would try to fill in stair number first. So we have a fixed number anywhere. And it's going to be equal to round number. So because at this point we should be able to calculate this and store this information into stair number, so we know how many stairs we need to basically instantiate. So in that case, we can create, for example, a for loop. No idea if that works. It can crash horribly. So yeah, just bear with me. So the max number would be, in this case, the stair number. If there are no typos, that should work. So for every amount of stair numbers, if that's 0, of course it's going to stop at 0. But for any stair number, we would iterate through and instantiate an object. Downside is we need to clear the instantiated objects whenever we are done with that. So basically we need to store this stuff anywhere anyways. So for that part, I probably create, as I said before, a list of objects which is going to be able, or where we are able to delete them anytime we are going through the next iteration. Once again, this is running in editor time, so let's try that out. So we create a list of game objects, and this is going to be just our stairs. We define that as being a new list of type game object, open close parentheses, close the line, with a semicolon over here, so we have access to stairs. Whenever we do something and we instantiate that, we can flush that directly into this list. And later on in the next iteration, basically, we're going to clear the stairs list or delete all the game objects inside. So it's basically looping the whole time, the whole time, the whole time until we are done with that. So probably I'm gonna create another extra function for that, so it's a bit code-wise a bit clearer, and we just have one call over here. So let's try that out. Once again, it can happen that we need to go into editor scripting for that even more. I would just create a new void create stairs. Once again, it can happen that this does 100% not work. We will see. So what we do is I'm gonna take the for loop over here and put this over there. And any time I want to do something is I want to instantiate a stair. And I want to, after that, flush that information into, into this list. Before we can do that, we need to have the stair over here. So public game object stair, let's say model or prefab, whatever. So, and from here, we're gonna grab the stair model. we want to make sure, of course, this is only being called whenever stair model is not equal to null. Otherwise, once again, we're going to have null reference exceptions, and we want to avoid that completely. I'm gonna put this over here. So what we now want to do is we want to instantiate stair model. And basically, we want to recalculate the position of every stair we're gonna have. In that case, we need to catch that first inside a game object, and give it a name, st for stair. You can name it whatever you want. Now we want to reposition that. So in every iteration, every stair needs to be added to and calculated by whatever the amount of I is. So in that case, first off, we want to say st dot transform dot position is equal to. And now what we want to make sure is that we reposition this one to based on where our bottom game object is, plus the actual calculated distance between the stairs. So the stair distance, which we have over here, or over here. Okay, so we're gonna reposition this one to be a new vector 3. And okay, and now we need to take care of, once again, the actual x-axis is going to be the current one, so the current one from the current game object. Then we need to lift the y-axis, so we say transform position dot y plus the stair distance, and then we need to multiply that by I. So I is our iterator over here, so whenever we iterate or multiply that by this, we're gonna always add up to the next distance. I'm gonna put this into pair of parentheses even if it doesn't need to be, because it's a multiplication and it will be added later on to the actual y position per iteration. And the last one is, of course, the transform dot position dot z or z value. So, and we need to close the line with a semicolon. So this is going to happen like the whole time. What we also want to do is that we flush st into the list. So we're gonna say a stair. I guess we're gonna rename this to be stair list. It's a bit easier to read. Stair list. So our stair list, and we want to add st to it, because that's the game object we were instantiating beforehand. If the normal instantiate does not work, once again, we're gonna check this out later on. We're gonna take a look into this. And before we do all this for loop iteration, we want to make sure that we clear the stair list. So stair list.clear, otherwise we're gonna have like hundreds of thousands game objects over there. Also, we need to iterate through the stair list and delete all the upcoming objects over here. We need to do this in front before we're gonna do that. So in that case, we loop through the complete list. So we can say over for or for each. I'm not quite sure which one is faster or easier over here. I guess for loops are faster than for each loops. In this case, for each game object, I'm gonna name it, I don't know, st again, because it's a stair in our stair list. We want to iterate through them, and what we want to do is we want to delete st, so we can say destroy. Probably we need to take a destroy immediate. And in here we're gonna need to put in the object. I'm not quite sure if that works the way it should, but we'll see. So first off, we're gonna delete all the stairs created, then we clear the stair list, and then we refill it. And of course, finally, we need to call create stairs over here. So create stairs. Once again, it can happen that this does not work. I'm gonna save. And later on, once again, we're gonna change onDrawGizmos into another function. So it's not like running the whole time, but only on change. So whenever everything is done and compiling, it should not do anything. I'm gonna deactivate this letter stair, I guess, just for sake of visualization. And I want to make sure that I put this letter stair anyhow into the corresponding slot where the stair model should be in. Let's see if that works. Okay, so nothing happens over here, but I also have no errors. Probably that cannot be accessed. Also, later on, we need to make sure that this is going to be child of our ladder objects. So whenever we are done with all of that, we need to make sure that our parent object is going to be the current one. So sd dot transform dot set parent, and I guess it's in this one is going to be this dot transform. So we're gonna make sure that the ladders or the stairs are going to be part of our actual ladder object, like this one. Okay, so nothing works, nothing happens over here for the ladder stair model, and I'm not quite sure what's going on. Maybe we're gonna do some changes here and there. Maybe we're gonna need to check this stuff out. I don't know. Nothing happens over here, so, and I have no coding error. So, and create stairs is called, well, hopefully. So, and when stuff is not working, of course, we need to debug all of that stuff. So let's see. If the stair model is not equal to null, so let's see if we are going to reach this point. Debug.log, or we can also print something like, I don't know, yes. So it should print yes whenever it comes into the stair model part over there. As you can see, it is doing it. It's doing it several times over here. So the stair model is actually not set to be null. So meaning we are entering this mono behavior, or actually this part. The downside is the stair model does not get instantiated anywhere in my scene. So maybe we gonna do and make a prefab out of it. Maybe that's better. So to do that, we're gonna drag this ladder stair over here, and I'm gonna create just a new folder for prefabs. No idea if that is necessary, but we'll see. And then I drag the ladder stair inside this prefabs. It's an original prefab. And then I'm gonna get rid of this one. So, and I wanna make sure that I take this and bring this over there. But it doesn't care about it. That's awesome. Let's do something else. Let's not clear this list, and maybe I'm gonna make this list visible. So it's a public list game object like that. So we see this is a list of nothing, of 0. So there's nothing in. So for the moment, we try to get rid of this. I just toggle that line commands over here and see if I get any stairs into that, and if that works in any case. So it says yes, but it doesn't care. And our stair list is still empty. So probably I'm gonna need to give it something like, I don't know, transform the position and quaternion dot identity. I have no idea. And maybe we need to typecast this as a game object in the end. So with a big G and test again. Once again, it may crash here and there, so nope, still nothing. So that's funny. Okay, so if that does not work, I just try to copy that line and just bring this over here. So it just does it once. And I deactivate this part. So maybe there's a coding issue I have no idea about. So just let's check it out. Okay, so as you can see, here we're gonna create ladder clones, and it's going to do the whole time. So, and we cannot stop anything about it except just, just changing code. So something is wrong over here, and probably the stair number is, that's why. Okay. So we did not set any stair. Probably we don't have any stair number, or it is calculated wrong. So probably we're gonna do the calculation of the stair number over here. Um, so I would, where is it? Toggle line commands. I'm gonna get rid of that. And I get rid of that. So instantiating that in runtime seems to work. I want to make sure that I put all of that. I want to make sure that this works at first. So, and in this case, I want to make sure that I calculate the stair number, maybe over here. Maybe I can print a stair number just so I know how many stairs there should be. Maybe there is a problem with that. So, debugging is your best friend. So, keep that in mind. So, and as you can see, stair number is calculated to be 0 over here. So that's why we don't see anything because, well, nobody knows why. So we're gonna need to find a way to why these numbers are not full. I guess it's the calculation is wrong. Yes, because that needs to be the y distance and not the x distance. Let's see. Okay, it still says it's 0. That's funny. Ah, okay. So I guess x distance, I'm not quite sure what y distance is. So I'm gonna print another message over here. Print y distance. I want to know if that is hi Yun Lee. Welcome to the stream. I'm gonna test out what the y distance is going to be whenever it's calculated, and y distance seems to be 1. And when we divide 1 by 30, I got a tutorial about inventory systems like that already. It's directly on my channel called Chrono Trigger something, Chrono Trigger Inventory. So we cannot divide 1 by 30, otherwise it doesn't work. So we would need to bring this one. Basically, this is the 30, and I would actually I would expect to have this number as being a 0.3. So like if 1 is 1 meter based on the scale, this needs to be 0.3 or something. So probably we're gonna do the other way, like calculating the distance by how many stairs we want to have. So maybe I'm gonna do the calculation vice versa, like taking the stair amount we want to have and divide y distance by the stair amount and take this as an input. So maybe that makes more sense in the calculation over here. So I'm gonna rename this one to be a stair amount. Since it's public, we need to do this into the Unity editor. And now we're gonna have like 30 letters in just a sec, I guess. Stair amount is now set to be 5. That's funny. So, and we still get 0. So 1 divided by 5, and then we do not want to round this then. So we can just, because it doesn't make sense, we need to return a float over here because we want to know the distance between those. So, and the stair number over here is wrong. We want to have the stair distance. Stair distance. Do I have something like that already? I don't. So I create, maybe this should be an integer. Doesn't make sense otherwise. We need to get rid of that. Then we have a float. Let's see. Stair distance. That's the calculated stair distance. Like this. And what we need is we need to basically bring this over here, and we basically can rename this one to something like calculate stair distance, something like that. I don't know. I guess I have a typo. There needs to be a T. Okay. So the stair distance now is the calculated stair distance, and we don't need to print this anymore. But we can actually print the stair distance just to make sure we have a comma, like 0 comma something. And the stair number is now a fixed number, so it is not automatically calculated. Over here, whenever we set this one in edit time, it should update this automatically. So for the sake of clearance, I probably toggle this one back. So we have an easier way to get rid of ugly content, I would say. So let's see, we're gonna have something like a 0.2. We're gonna clear the console and move around a bit. So the distance would be now 0.2 because 1 meter divided by 5 is going to be that. So still, with the amount over here, we still cannot see anything. So I'm gonna get rid of that once again, just in case I wanna see anything at first. Don't forget to save in between and save often, of course. And still, I don't get any of these 5-letter stairs. Did we disable something? Or is there something wrong? We can always go into debug line mode so we can see what the calculated is. Okay, so the stair number is what? Let's see where stair number is represented. Okay, we do not want to take stair number. We want to take a stair amount instead. So this one here needs to be a stair amount as well. Okay, so that should fix it. I still go and toggle line command over here. And now we have 1, 2, 3, 4, 5 clones of stairs. They are wrongly repositioned or positioned, and something is flying over here. That's funny. Okay, so this is now the distance they're gonna add. That's absolutely phenomenal. So we have them as a child of that, and they are going to be repeatedly updated and recreated because we are now deleting them and creating, deleting, creating, and so on, because they are currently landing into this for each. They're gonna get destroyed. Then we clear the list and we refill this one again. What we now want to do is we want to reposition this one correctly, because currently we take stair amount, which is wrong. What we want to have over here is the stair distance. We calculated or set or something like that. No, I don't want to do anything of that. So we want to do stair amount over here. No, not stair amount. Again, the stair distance. So because we want to multiply that and add this to the current transponder position. And the first one might be needed to be not at 0, but lifted already by its amount. So we're gonna need to recalculate that. But first, let's see what's going on with our 5 stairs. And as you can see now, we have these 5 stairs. Based on the settings of the 5 stairs, this is now going to be filled automatically. And Of course, it is still not completely procedural because we want to make sure that it is filling based on the distance, as well as we want to have this one where the first one is and not the second one. So what we can do is we can probably add a 1 to this eye over here, something like that. Maybe that can be a problem later on, but for the moment it's the easiest way, I guess, to fix that. So we should not have anything on the bottom, but the first one should be here, and the last one is rather on top, as you can see. We can also negate this by 1 again, because probably that's not what you want to have this one at the most upper part over there. So maybe you want to have something like a distance, a small distance over here and a small distance over there. So these are not spreaded over the complete part, but maybe reduced by, so the distance reduced by something, by 0.1 or anything like that. I don't know. So in this case, we can, for example, do this calculation directly over here in the stair distance of that. For example, let's see, stair distance minus 0. I don't know, 0.5, 0.5 f or something. So I'm gonna put this into parentheses again, just in case, because I want to make sure that this is calculated beforehand, and then we multiply that by I plus 1, which should reduce the complete one over here. Okay, so that's a too huge number, 0.01 or maybe something like that. I don't know. That's something you need to test like on your own whenever whenever you create stuff. So as you can see, I reduced now the distance between that. The first one is kind of low over here, but also we got not the problem that in top over there we do any false calculations. What is procedural now? Basically, these stairs, whenever we change the size, can see they're automatically fitting the amount. So this is the procedure part on the one side of the mark. There is another problem with that, is once again, if you want to have always the same distance, but you don't want to go and add this by hand, which you easily can because we created like all necessary content for that, and we can basically just say, okay, no problem. We can just say we want to have 10, 10 stairs over here or whatever they are called. We're gonna take the top goal and then we just spread them apart however we like to. So based on that, even this is now working. Let's see what's going on when we now reposition all of that. As you can see, that since these stairs are, basically they are just child of our base ladder object, we are absolutely able to, make use of that. So we can now bring this one down over here, or let's recalculate it again. We have all our print messages, and we now have a 2-meter ladder without any problems overall. Pretty decent. So there are still things left. And these things are, as you can see, these stairs just need to scale on their own, let's say, what is it? I guess it's the x-axis. It's not clickable because they are refreshing like the whole time. But these ones need to be scaled onto the y-axis based on the distance from that. The downside is that these are seen as a scale of not actually as a scale of 1 and not of their actual size, which is, I guess, 30 centimeters. We can see this easily whenever we are selecting our ladder stair over here. You see that the scale is a 1. So what we need to do is we need to take this in consideration. If I would be able, or if I would in original just create this one as being a 1 meter, then it would be easier for us. So maybe that is something I need to take in consideration later on as well. But when we would say, okay, this is a 30 centimeter part, but is now with a scale of 1, we need to multiply that by, I don't know, whatever number to get it right. like add something to it or multiply that or divide. I don't know. So basically, if you are going to go for procedural content, you might want to work always with full sizes and full numbers over there. So they are not like that. They don't have a difference between the actual scale and as well as the actual length. So, and that's what we need to take care of and see how can we fix that. If you like the part where you're gonna take a fixed amount, put it in, and update it accordingly to whatever we need, then stair amount in this case is absolutely okay. You can once again also go the other way around, but the calculation needs to be different because you need to take the full number and divide this by comma somethings. Like comma 2 would be something like 20 centimeters as a distance between that. So your actual float or the stair distance should be once again something between 0 and 1 to, or actually 0 and 2 maybe, depending on once again this amount. So because the actual distance calculated over here in our x or y distance is always starting at 1 meter, so it's always one when it starts, and when we scale this one up, it has a scale of 2, but it is like 2 meters. And when you want to have a distance of 20 centimeters, it's always a 0, comma something, a 0, comma 2 number or something like that. So that's why the calculation beforehand did not work the way it should. Good. What else? Yeah, we want to make sure that all these stairs are now calculated correctly in their size, like spread it apart. In this case, we're gonna be able to calculate them hopefully anyhow rather good over here. So let's take a look into this. Once again, 1 means it is 30 centimeters, so we need to, I guess, do some calculations for the length or the scale of our actual, yeah, of our actual part over there. We need to do the scaling always before we're gonna set parents, otherwise we have a wrong set scale because it's taking the scale in consideration from the original game object. And if there's something weird happening, we don't have this one inside our calculation over there. So what we're gonna do over here is we're gonna take a look into this. First, we wanna catch or just store this information anywhere. And since I know it's a 30, probably I can do a calculation with that. So I'm gonna create a new vector. I'm gonna name this one maybe scale is equal to new. Actually, we can directly take the scale from that, but we need to take once again the 0.3 into consideration. So probably I'm gonna set this as a start value and calculate it from there. How can we do this? I don't know. I just create the vector first, so I only want to make sure that these ladders or the stairs are going to be or scaled on the x-axis. So in that case, it's going to be so x is a 0.3. That's what I know. The other ones, like the y and z value in the scale, are basically 1 and 1. So, and since that is a 1 already, I need to anyhow calculate it so that once again the 1 is basically seen as a 0.3. Maybe that's not a good deal over here. And I guess I cannot override it the way I would like to. Any ideas are always welcome. So if you guys in the chat now have any idea about it, feel free to send it out. And I try to figure that mathematically rather, hopefully rather soon. The easiest is probably taking a 1 meter piece and update this one. So that might make it easier. No, we're gonna do this probably a bit different. Maybe we are not doing directly the scale, but the size of the mesh. But for having the mesh, we're gonna need to have a collision object which is able to calculate the mesh size. So, or we can take the mesh boundaries. Let's see. St dot get. I gonna eyeball that right now because I'm not quite sure. So get component of type. I guess it's the mesh renderer component which knows this information. Dot. There might be something like a bounds. Dot size, and this should be a vector, and this should also have an x value. So this is basically the distance between, or the size of that. Maybe we're gonna not do this. Maybe we can anyhow take this bound size x into consideration, and the rest we gonna keep maybe as 1 and 1. I don't know. And maybe we can take this bound size x of the mesh, of the original mesh, and anyhow transform it, like resize that one based on the scale. No idea, actually. I guess we can just print scale at this point. So we're gonna see what the actual size at least is of that. So as you can see over here, it's a 0.3, but its scale is once again 111. So if you need to measure, by the way, game objects or any 3D models, you can always do this by the mesh render component. Okay, so now we know that this one is going to be this, but the scale is actually 1. How do we do this? I don't know. So let's see. I'm trying to figure that anyhow out, how I could take this into consideration. Since I cannot put this between 2 points to do the scale, I guess I cannot do this. I need to anyhow. Can I talk to that? Can I talk to the mesh renderer and tell or overwrite the size of that? I guess not, because I just can read this information about it. And as you can see, once again, this is the scale over here. Maybe I can anyhow scale this one up so far that like this prefab so far that the scale would match the same as the size would over here. So what would be the idea about it, or what could I do? Let's see. I know that this cube, I can basically just do a snap with the V key and just snap this over here. I know that I can, whenever I would scale this one so far, that I would be somewhere over here. I know that maybe that's just a 3. No, it's not a 3. So 3, 3 maybe. Okay, so actually with a scale of 3, 3, this would be 1 meter right now. In its x-axis. So this, if that is 1 meter, 3, 3, maybe we can take this number as a consideration for the calculation over there. So we're gonna take 3, 3, and then we divide or multiply that. Whoa, I didn't want it. Then we can probably multiply that by this. What did I activate it right now? What the heck is going on? Let me just, yeah, save that and reopen this. So, what's here? Okay, yeah, then never mind about scale. So, what what I will do is just multiply whatever the input is by 3.3, I guess, and then we see what's going on with that, or yeah, something like this. So what we can do is we're gonna store this vector once again. Vector s, I don't know, is equal to a new vector 3, and since we know this number, the actual vector is now 3.3f, comma, 1, 1. So this is the actual length or the actual scale. We want to set the scale of that divided by, or probably, yeah, divided by the y distance, I guess. Let's test it out. If I'm wrong, then it is what it is. So we want to set the local scale of our st to be equal to whatever we calculate in s. So what we can take now is the scale of 3,3 and divide this by, I hope so, by the x distance. So if we're gonna take that and divide this by 1, it should stay the same. If we divide it by more or less, I don't know, it should update automatically. Let's see what's going on with that distance of these letter feet. So maybe we need to multiply that because these are now, let's see what they do. When we are taking our top goal and we drag it away, as you can see, it goes the other way. So we do not want to divide that, but maybe multiply that by x distance. Let's see what's going on with that. So as you can see now, we figured out how to automatically scale them with the correct distance, like these stairs are now going to follow up as well. We're gonna be able to make it high and low or whatever. We're gonna clear the console, and we're gonna first off get rid of all the print lines we're gonna have over here. Maybe I'm gonna rewrite it a bit, but basically that's everything what we need to have procedural staircases or stairs overall. I don't think that these are going away. I have no idea what they are going to do over here, because scale is only over here. I maybe gonna save this again and close the script and reopen. Doesn't matter. I don't know. However, that's the way I would basically try to fiddle around with these. So what we can now try is, in the final step, is create another prefab, or actually any kind of a prefab. For example, we can do any setting, and what we can try now is we need to basically get rid, since this is a procedure one, let me just do some test first. I'm gonna place my camera so that we can see this in the game view in the bottom. So I go to Asset, Game Object, Align with View, so we can see what's going to happen when we are pressing play. Since that on Gizmos is not running whenever we press play, and probably we don't see anything. Probably it works as it should. For now, it is doing everything it should. Okay, so instead of having this onDrawGizmos function running the whole time and so on and so forth, we probably only want to do the calculations on validate, because it might not update everything correctly. So we say on validate, so whenever we validate the input, and we're going to do any change, basically, only then we want to do any changes. And that's the problem, as you can see, of the destroy immediately is not permitted during the physics trigger contact, whatever that means, and on or basically in the on validate possibility. So probably we're gonna do not destroy immediate, but just destroy. Let's test it out. So we're gonna say destroy st, that's the one we are looping through, and save and see what's going on after the compiler is done running. So now we can clear the console and take one of our top goals and see if we do any changes. Oh, we don't see anything. Okay, so what we see over here is on validate does not do whatever it should. That's awful. So we cannot do this with on validate. That's actually bad or sad, I would say. So in on draw gizmos, we're gonna do this setting. And so once again, this is not running in the build, so we probably want to get rid of that whenever we are done with setting up our ladder overall. So what do I mean by that? We would, or I would, when I'm done with the setting of my ladder, I would try to create a prefab. I just drag this ladder in, and as you can see, it is as it is. You know, it is setting up as a game object setting as we could. What we can now do is from that particular ladder prefab, we can get rid, or we try to get rid of this component, of the complete procedure component. So when we are now dragging the ladder in here again, we don't have any recalculation possibilities because the script is gone, but the settings are going to be the same. Once again, since Ondro Gizmos does not run in runtime, like later on whenever you do something, of course now it works because it is in Unity editor, but whenever we are building a game out of that, that would not work. So we need to, or actually you need to make sure that you save the prefab whenever you are done with the ladder, and then you can do the changes. As you can see, I cannot do any changes to this particular ladder because even that, since it was a prefab, deleted everything here as well. So, I don't need this anymore. I don't need this anymore. And in here, since I deleted like everything right now because I got rid of the script because it was a prefab, I need to re-add like all this information about it pretty quick again. Nothing fancy at all, but that should be good and pretty simple to do. Left ladder lag, and we have a right ladder lag. We're gonna have our stair model. It sits in the prefabs. Model stairs or ladder stair. Then we're gonna have a what do we need? The top. So left ladder top, right. Whoops. Right ladder top. And so you can, by the way, always change 3D models if you don't like them. And what else? I don't know. Um, I guess the other ladder clones over here are, since they are stored in the prefab, we're gonna need to delete them. Otherwise, this does not work anymore. And now we can rework everything over here. So since this is now a prefab, we can basically always go and create another one. We can make it as any size, like from here to here. No, this is not working anymore. Okay, so that's totally fine. We need to override this letter over here with that letter prefab invalid stuff, blah blah blah. So, but whenever we are now taking this new one over here, we're gonna be able to do that. And we need to basically get rid of the other ones over here as well. So still, this prefab work is basically the most horrible content, I would say. So you're gonna need to find a way to work with these, like with all these information and stuff like that. So if you want to have 10 over 1, it's so funny that this calculation is not calculated anymore. The top goal is not calculating the ladder again. Anyways, let's see if I can pretty quick fix that. I guess I need to get rid of revert all. No, that's not what I wanted. So these letters are just anyhow inside, or these letter stairs are inside the clone or inside the prefab. So um, and they get overwritten like the whole time, so that's not a good one. So maybe I'm gonna make something like a 0. And in here, now it is updating it to the corresponding one. Yeah, that's good. So in the prefab, we need to store something like a 0, 0 stairs. And in the actual setting on the final one, we can basically, whoops, that 140 is a bit huge. We can put this together like that. Good. So as you can see, procedural stuff takes time to create. Procedural stuff is on the long run probably, yeah, giving us some freedom. I can easily duplicate this, I guess, and change it to my needs. Let's see. In the end, it is important that we are understanding like everything over here. Um, so if that is 0, yeah, we're gonna, all these copies over here are not directly part of the prefab. So we always need to delete them from this and create new ones. Or actually, whenever we do this copies over there. So it's better to always take the actual prefab over here and update this into the scene. Anyways, thanks a lot for tuning in. I still hope you enjoyed this one. It was a rather long tutorial, and I predicted that already. So, or actually live session. And if you have any questions, of course, feel free to ask in the comments below. And if anything else, like if you want me to teach you content, if you need help with your game or anything else, feel free to check out my website and hire me, or check out my Udemy courses where you can learn quite some stuff over the next, I don't know, couple of sessions. So thanks a lot again for tuning in. I hope to see you in one or the other streams of my own, and take care. Bye bye.